In this video, I'm going to solve every question from the 2025 Intermediate Maths Challenge, which is one of the UK's main maths challenges aimed at students aged 13 to 16. There are 25 questions in total, all multiple choice, and in previous years you generally need about 9 or 10 right to get a bronze certificate, 12 or 13 to get a silver, and maybe around 16 or so to get a gold, and 19 to 21 out of 25 to qualify for the Olympiad round. If you're interested in exactly how all of the scoring works and the grade boundaries for other years, take a look at the Mathsaurus website, which has a lot more information, as well as a totally free course where you can practice all of these questions and a tool where you can enter your answers and see what you would have got right. But for now, let's start the 2025 paper here. I'm going to put timestamps below so you can jump to the questions you need, or you can work through the whole paper with me and pause the video at the start of each solution. So don't forget to let me know how you get on in the comments, and let's get started with the 2025 Intermediate Maths Challenge. Here's question 1 of the Intermediate Maths Challenge from 2025 then. Which of the following expressions has a value closest to 0? You might start looking for patterns here, but it's not really worth it. They're quick questions to work out here, so we just work out the answers. A is 10 minus 24, which is minus 14. B is 12 minus 28, which is minus 16. C is 12 minus 30, which is minus 18. D is 10 minus 30, which is minus 20. E is 6 minus 28, which is minus 22. The fact we get a sequence here might make you think there could be something to investigate later, but don't do it in the challenge here. We need to just get the answer and move on quickly. The answer here is A, that's the closest one to 0, minus 14, and that's the answer. What is the remainder when 2652134 is divided by 13? Well, we can just do a long division here, but we're not going to have to do a lot of work as we do it, because if we think about the 13 times tables, that's 13, 26, 39, 52, that will be plenty for us to do this question. 26 divided by 13 is 2, I'd get a 0 in the next column, I'd look at 52, which is 4 times 13, so that would give me a 4 here, I'd then get a 0 in the next column, and 13 is of course just 1 times 13, and that leaves us here with a remainder of 4. Nice, quick, easy calculation. As long as we spot those multiples of 13 there, we get 4. And that's really because if you think about how the division works here, we've got this number 26 with lots of zeros, 52 with some zeros, and 130. They are all multiples of 13 that we add together, and then we're just left over with this 4, which is the remainder. And so, as we've already seen, the answer here is D4. This is a nice little geometry question from the Intermediate Maths Challenge. Let's make the diagram a bit bigger. We want to find the angle PRT when we've got this square and an equilateral triangle combined. So because we've got a square and an equilateral triangle, they're both regular shapes. We know that all of these side lengths are equal. So that in particular, that means that TS and SR are equal in length, and that this triangle TSR is an isosceles triangle. We're always on the lookout for isosceles triangles in these sorts of maths challenge questions. Now, the non-equal angle in the isosceles triangle is made up of a right angle and the 60-degree angle from the equilateral triangle. So we've got 90 plus 60 is 150, is that angle TSR, and then let's call the other two angles X. So angles in a triangle sum to 180 degrees, so we've got 2x plus 150 is 180, subtracting 150 from each side we get 2x equals 30, and dividing by 2 we get x equals 15. Now that is one of the answers to the question here, but be very careful because we're asked for the angle PRT, not that angle, so that's the angle in here. By symmetry, this x would also be equal to 15. If we did exactly the same calculation on the other side of the diagram, we'd get the same value for x. So those three angles there, the two x's and the y, add together to make the angle in the equilateral triangle, which is 60. We know x is 15, so 2x is 30. 30 plus y is 60 gives y equals 30, and this time that is the angle we're looking for, so the answer here is E. So this was question 4 of the Intermediate Maths Challenge from 2025. All Felix's cats are normal cats. Together they have 12 more legs than they have tails. In total, how many ears do they have? Well, each cat has 4 legs and 1 tail, so that means that each cat has 3 more legs than tails. So if we take that number in the question, 12, and divide it by 3, we get 4. 3 times 4 is 12. So that means if we want 12 more legs than tails, that would be 4 lots of everything we've got on the left here, so that's 16 legs and 4 tails, which corresponds to 4 cats. Be careful here, the answer is not 4, it says how many ears do they have, and each cat would have 2 ears, so that means we'll have a total of 4 times 2, or 8 ears, and that gives us an answer of 8, which is D. Question 5 has a lot of 5s in it, and I've just made that a lot bigger to make it easier to see here. The idea of this sort of question is just to remember that when we're working with bracketed expressions, we want to work from the inside out. So I'm going to start with this 5 divided by 5 and say that's equal to 1. The next 5 divided by 5 is also equal to 1. The next insidemost bracket here then is 1 divided by 1, and that's 1. So I've got 5 divided by 1 divided by 5, or 5 divided by 1/5, and 5 divided by 1/5 is the same as 5 multiplied by 5 over 1, or just 5 multiplied by 5, and 5 times 5 of course is 25, and so that gives us an answer of E25. Not too bad if you're careful. Odd and even number questions are certainly a common maths challenge topic. This was question 6 of the Intermediate Maths Challenge from 2025. Owen chooses a positive integer n so that 3n plus 7 is an even integer. Which of these is an odd integer? Well, let's start with the 3n plus 7. If that is even, if I subtract 7 from an even number to get 3n, I'll have an odd number, right? Any even number minus an odd number is an odd number, so 3n is odd. And again, if I take 3 times an even number, that would be even. 3 times an odd number would be odd. So here it must be that n is an odd number. Again, if you like, I've got, this must be an odd multiple of 3 here, 3n. If I divide it by 3, we're definitely going to get an odd number, couldn't be even. So if we look through all the different options then, if I subtract 1 from an odd number, I get an even number, right? Odd minus odd is even. If I add 3 to an odd number, I also get an even number. If I take, for C, 3n plus 2, well, if I think about 3n first, we know 3n is odd, we already spoke about that at the start, and then when I add 2 to an odd number, odd plus even is, again, another odd number. So we can see that C looks like the right answer, but let's just double check the others. 4n is an even times an odd, which is even, and 5n would be an odd number. An odd plus an odd, 5n plus 3, would give us an even number, so it's certainly 3n plus 2, and the answer here is C. I can swim faster than you, said the dolphin to the shark. That is not true, said the shark to the dolphin. You are both wrong, said the octopus to the dolphin and the shark. You are right, said the starfish to the octopus. How many of the dolphin, shark, octopus and starfish were telling the truth? A bit of a crazy sounding question, this one, but if we break it down logically, not too bad at all to analyse. Let's think about that first statement. So the dolphin says to the shark, I can swim faster than you. Very often in maths, just finding efficient notation can make things a lot easier. So I'll just say that the dolphin here says d is greater than s, i.e. the dolphin's speed is greater than the shark's speed. So this represents the statement the dolphin can swim faster than the shark. The shark says that's not true. Well, what's the opposite of d greater than s? It's d less than or equal to s. So it's saying that the dolphin is not faster than the shark, the dolphin's speed is less than or equal to the shark's, in fact. The octopus comes along and says, you are both wrong. Well, actually, they can't both be wrong because these two statements together form all possibilities. Either D is correct or S is correct here, so they just can't both be wrong. The octopus's statement must be false. And then that means when the starfish comes and says, you're right to the octopus, well, the starfish must be wrong as well because we know the octopus is wrong. And of course, we know that exactly one of these two statements from the dolphin and the shark is true, and that means that overall out of these 4 statements, exactly one of the statements is true, and so the answer here is B. What is the value of 34 and 1/7 divided by 17 and 1/14? Well, a very inefficient way to do this question, at least if you don't have a calculator, would be 34 times 7 plus 1 over 7 is 34 and 1/7, i.e. write them as top-heavy fractions, and also write 17 and a quarter as a top-heavy fraction. 17 times 14 plus 1 over 14, you'd get that that's 239 over 7 divided by 239 over 14, which is 239 over 7 times 14 over 239, turning the second one upside down and multiplying. So the 239's cancel, we get 14 over 7 and we get 2 and we get the correct answer. So a much better way to do this, because this is a maths challenge question where you don't have a calculator and we want to dispatch this quickly, is to think about this as 34 and a 7th over 17 and 1/14, and change that 1/7 to 2/14, and remember that mixed numbers mean adding those two together, so it's 34 plus 2/14 and 17 plus 1/14. Now the top is, well, 2 lots of 17 is 34 and 2 lots of 1/14 is 2/14. So this is like 2 lots of 17 plus 1/14 over 17 plus 1/14. Good students here wouldn't write any of this down, by the way. They might just notice that the first one is double the second and then move on immediately. But I'm just trying to show you the structure here. So we can cancel the 17 and 1/14 top and bottom. We've effectively noticed that that first number is double the second one, and we get an answer of 2. And so the answer here is A. This is a nice little counting puzzle that was question 9 of the Intermediate Maths Challenge in 2025. Lottie wants to colour 2 rows and 2 columns of the 4x7 grid shown so that the coloured rows do not touch and also the coloured columns do not touch. In how many ways can she do this? Well, let's add some notation here so I can explain this to you clearly. We've got the rows I'm going to call A, B, C and D, and the columns 1, 2, 3, 4, 5, 6 and 7. Let's think about the options for the rows. If we don't want them to touch, if we're going to do this systematically, let's start with the ones that have row A in it. So A could go with either C or with D, and then row B can only go with row D, and then that's all the options because C can't go with D, and we've included all the ones that can have A and B in them. For the columns, I could say, well, let's start with column 1. Well, column 1 can't go with column 2 because they would touch, but it can go with any of the others. So it can go with 3, 4, 5, 6 and 7. Similarly, column 2 can't go with column 3, and we're not going to count again anything with smaller numbers. So I'm not even going to think about column 1, even though it's also not possible because they would be touching there. But 2 plus 4, meaning 2 and 4 is a possibility here, 2 and 5, 2 and 6 and 2 and 7. Similarly, I then go on to column 3 and I can do 3 with 5, 6 or 7, 4 with 6 or 7 and 5 with 7. Strong students wouldn't necessarily write all of these out here. They might just notice the structure here, that the number of rows is 2 plus 1, which is 3, and as you go through the columns, we've got 5 choices for the first one, then 4 for the next one, 3 for the next one, 2 for the next one, and 1 for the final one. The sum of those is a triangle number. Triangle numbers come up an awful lot in Maths Challenge questions. So when I add these together, I get that triangle number 15. So there's 15 choices for the columns, 3 choices for the rows. I can effectively take any choice for the rows combined with any choice for the columns. That gives us a total then of 3 times 15, or 45 choices in total, and so the answer here is A, 45. They do love getting the current year into Maths Challenge questions, and so no surprise here that we saw this in the 2025 Intermediate Maths Challenge. What's the value of the square root of 2025 squared minus 2024 minus 2025? And the key here is to think about the structure of what's inside the square root rather than doing a big calculation here. So 2025 squared, I could change the order of the 2024 and the 2025 to make it minus 2025 minus 2024, because then I'm really thinking of this first term here as 2025 times 2025, and then if I combine it with the second term, the minus 2025, it's got this kind of structure: 2025 lots of something minus that same something, right? 2025 lots of x minus x. I know some students find it very helpful when I write it down like this, because then the structure here of the algebra is the same as with the numbers, with x equal to 2025. So if I subtract x from 2025x, I get 2024x, right? So what am I saying here? I'm saying that I've got 2025 lots of 2025, I take away one lot of 2025, and so I end up with 2024 lots of 2025, okay? And now I've just got to do the same thing again. I subtract the 2024. Well, again, this has also got that structure, 2025 times y minus y. This time y is 2024. So I'm saying I've got 2025 lots of 2024. I subtract one lot of 2024, and I'm left then with 2024 lots of 2024. Now we remember that the question asked us to find the square root of all of this stuff, and of course the square root of 2024 times 2024 is just 2024, and so the answer here is C, 2024. You need to be good at algebra to answer this Intermediate Maths Challenge question. Emily multiplied 2 integers together. Her answer was 360. Finlay increased each of Emily's integers by 1 and then multiplied the 2 new integers together. His answer was 400. What was the sum of Emily's 2 integers? So let's write this down with algebra then. Let's say that Emily's integers are m and n, so that m times n is equal to 360. So Finlay is going to increase these by 1 to get m plus 1 and n plus 1, and then multiply those together and gets 400. So if we multiply out these brackets, we get m times n plus m plus n plus 1, that would be equal to 400. But look, we know m times n is 360, so we can replace mn with 360, and the answer to the question is the sum of Emily's 2 integers. That's what's left in the algebra here, m plus n. So if we rearrange to make that the subject, m plus n is 400 minus 360 minus the 1. That gives us 39. And that's the answer to this question, A, 39. They love ratios questions in the maths challenges, and this is quite a classic one. Jane's farm is home to many cats and dogs. At the start of the week, the ratio of cats to dogs was 3 to 5. Then 32 cats but no dogs arrived, and the ratio became 5 to 3. How many dogs are there on Jane's farm? So the initial ratio of 3 to 5 we can express as an actual numerical, or I should say algebraic, amount here by saying if the ratio of cats to dogs is 3 to 5, there must be some value of x, some whole number x here, where the number of cats is 3x and the number of dogs is 5x. So writing it as the actual number, or an expression for the actual number, allows us then to say, okay, these 32 cats arrive, so then there'd be 3x plus 32 cats. The number of dogs doesn't change, that's still 5x. But this new ratio is in the form 5 to 3. So we can turn that into an equation. The ratio being equivalent here would be the same as saying 3x plus 32 divided by 5x equals 5 divided by 3. You could write that straight away if you wanted to, if you were confident with ratios, as this next line, 3 times 3x plus 2 equals 5 times 5x, or 25x. Multiplying out the brackets then gives 9x plus 96 equals 25x. Subtracting 9x from each side gives us 96 equals 16x, and then x is just 96 divided by 16, which is 6. Now that's not the answer to the question. We're asked for how many dogs there are. The number of dogs, of course, is 5x, so we just do 5 times 6 to get 30, and that's the answer to this question, E30. The product of the first 3 numbers in the box below is equal to the product of the last 3 numbers. What is the value of x? I don't think this is too hard a question if you just approach it methodically here. Let's write down the product of the first 3 terms, x times 120 times 496. That's equal to the product of the last 3 terms, 496 times 360 times 48. I suppose the thing you've got to avoid doing here is actually doing any of the multiplications. We really don't want to do that. We want to spot there's a 496 on both sides of this equation, and so it must be that x times 120 is 360 times 48. And then again, notice that 360 is a multiple of 120, so we can divide both sides by 120 and just get that x is equal to 3 times 48, and 3 times 48 is 144. It's the same as 3 times 4 times 12, or 12 times 12, which brings it into your times tables. However you work that out, we get x is 144, and so the answer here is E. Recurring decimals are a recurring topic for the Intermediate Maths Challenge. That's why I've put sections in my Go for Gold courses about them, where you can really learn and practice lots of different questions, like this one here that came up in the 2025 paper. What's the sum of these recurring decimals? Well, recurring decimals with just one number recurring are ninths. So 0.1 recurring is 1/9, 0.2 recurring is 2/9, 0.3 recurring is 3/9, and 0.4 recurring is 4/9. So if we add those together as fractions, we get 1 plus 2 plus 3 plus 4, which is 10. So that's 10/9. 10/9 is 1 and 1/9. And again, that 1/9 is 0.1 recurring. So 1 and 1/9 would give us 1.1 recurring. And so the answer here is A. Here's an interesting fractions question with some powers in it. Now, if you've studied algebraic fractions, you'll know you're always on the hunt for factors in algebraic fractions. If you can factorize something top and bottom and you find that it appears, then you can cancel it out. We've got a numerical fraction here, but we want to think about it a little bit like these were algebraic terms, really. So if we think about the numerator first, 3 to the 6 minus 3 to the 4, that's got a common factor of 3 to the 4, right? So it's 3 to the 4 times 3 squared is 3 to the 6, and then 3 to the 4 times 1 is 3 to the 4. So this is 3 to the 4 times 3 squared minus 1. 3 to the 4 is 9 squared, or 9 times 9, which is 81. And 3 squared minus 1 is just 9 minus 1, which is 8. So that's 81 times 8. And if we do the same on the bottom here, we've got 2 to the 9 minus 2 to the 3. There's a common factor of 2 to the 3. So it's 2 to the 3 multiplied by 2 to the 6. To get 2 to the 6 times 2 to the 3 is 2 to the 9, minus 1 again. And this time 2 to the 3 is just 8. 2 to the 6 you can work out is 64, and so 64 minus 1 is 63. So overall the answer to this question is 81 times 8, over 8 times 63, we can cancel those 8s. That leaves us with 81 over 63. Now there's a common factor of 9 top and bottom, which we can cancel out to get to this answer 9/7, and so the answer here is D. I really like this question from the 2025 Intermediate Maths Challenge. We've got David who likes books. He only ever pays 99p or 1.99 for an electronic book. In the last few months, he has spent 56.56 on electronic books. How many electronic books costing 1.99 has he bought in this time? I might just say books as we go on here rather than saying electronic books over and over again. So the key here is to realise that all of the amounts for each book end in 99. And if we add those sorts of numbers together, like 99 plus 199 would get us to 298, add another 199, it would bring us to 497, add another 99, it brings us to 596. Effectively, we're always going to get a whole number of pounds minus an extra 1p. If you wanted to write that down algebraically, we could say if n was the number of 99p books and m was the number of 199p books, or the 199 ones, that 99n plus 199m, you could write it as 100n plus 200m minus n plus m, right? So it's like a whole number of pounds minus n plus m. Now, the number of pounds and pence we've got here is 56.56. So it must be here for this number of books that he's bought 44 books, or I suppose possibly 144 books, but 144 would clearly take us over the amount here. So it must be that n plus m is 44, and the other part of the equation here, 100n plus 200m, would be £57 or 5,700p, and that would bring us to the 56.56. So we have that m plus n must be 44, and then this other part of the equation, 100n plus 200m is 5,700. We could write that in pounds instead, or divide both sides of this equation by 100 to get n plus 2m is 57. So we've then essentially got simultaneous equations here. N plus 2m is 57 and n plus m is 44, but they're easy simultaneous equations to sort out. If I call them a and b and I just subtract equation b from equation a, we're just left with just m on the left hand side, and 57 minus 44 is 13 on the right hand side, and that's actually the answer to this question, because m was the number of £1.99 books, and so that's the answer, B13. I think I've got a really efficient way of solving this problem, although there are many ways to do it. We've got dark green paint made by mixing blue and yellow paint such that 60% is blue, and light green paint is made by mixing blue and yellow paint such that 60% is yellow. Now, Pablo is mixing dark and light green paint such that 60% of the mixture is dark paint, and we want to know what the ratio of blue to yellow in Pablo's paint is. So you could do this in all sorts of ways, but because we are looking at a ratio as the final answer here, just writing everything down in ratios is quite a nice way of solving this. So if we look at the dark paint, the ratio of blue to yellow would be 3:2. That would be 60% blue, 40% yellow. In the light paint, the ratio of blue to yellow would be the other way around. It would be 2:3, 40% of one and 60% of the other again. Right, now, because these have the same total number of parts, we can think, oh, imagine this is just 5 litres of dark paint and 5 litres of light paint, right? And they would both be in those ratios. I'd have 3 litres of blue, 2 litres of yellow, or vice versa in each lot of 5 litres. So when I mix the dark and the light paint together with 60% dark and 40% light, I could also apply that ratio and say, okay, well, that's like just taking 3 lots of the dark paint for 2 lots of the light paint. So you've got to be very careful here. This method, you'd have to adjust if the total number of parts of the ratios weren't equal, but because they are here, I can just add together 3 lots of the first ratio to 2 lots of the second ratio. So that would be 3 lots of the dark would be like saying I've got 9 litres of blue and 6 litres of yellow, and in the light paint 4 litres of blue and 6 litres of yellow, and then I just add those together and say, okay, the total mixture then is going to have 13 litres of blue and 12 litres of yellow, and that gives us a ratio of 13:12, which is the answer here, which is D, for a very, very efficient method. This is a classic maths challenge geometry style question, and it has been pointed out to me that even though this was a real intermediate maths challenge question, there is possibly a problem with the diagram here, and I'll show you that at the end. But we can still solve it if we take the approach that I think most students would have thought about here if they were to get it right. So we've got two circles that each touch three sides of a rectangle measuring 36 by 26 centimeters, as shown in this diagram. And I've just made a couple of extra copies of that diagram. And it does at least tell us that the diagram is not to scale. But actually this diagram is so badly not to scale that arguably it might even be a little bit misleading. But I do think we can solve it here. What is the distance between the 2 points where the circles intersect? So, first thing I notice here is that if I look at the 26 centimeter side, that's just the same as the diameter of a circle. So I've got two lots of the radius, or the diameter is 26, and the radius of the circle is 13. If I look along the other line here, this would be 36 centimeters. I'm drawing this parallel to the sides of the rectangle. That would be made up of, again, two lots of the radius over here for the first circle, two lots of the radius over here for the second circle, but I've overcounted this bit in the middle twice. Let's call that x. So what we'd have then is 2r here plus another 2r on the second circle there. That overcounts the distance horizontally by x, so if we subtract x, that would give us 36. But we know that 2r is 26, so this is 26 plus 26 minus x equals 36, and x then is two lots of 26, which is 52, minus 36, which gives us 16. Now we want this length here on the second diagram between the two intersection points, and to get that we're going to draw a triangle in here. Now this horizontal distance here is the radius of the circle, it's 13, and I want the bit that just goes to the red line, not all the way to the other circle. So this part here in orange, that's exactly a half of the x that we just worked out, because x goes that whole distance across the overlap, so half of the overlap here would be a half of 16, which is 8, and that means that this part of the triangle here is 5, and you can start to see how sort of wildly out of scale this diagram really is, because this radius up here is meant to be 13, and that horizontal distance is meant to be 5, but that gives us a nice right angle triangle. It's a Pythagorean triple that you might just recognize, otherwise you have to work out the square root of 13 squared minus 5 squared, which is the square root of 144, which is 12, but that 5, 12, 13 triple comes up an awful lot, so it's worth memorizing. So that means that the vertical distance we're looking for is two lots of 12. 12 plus 12 is 24, and so the answer here is E, 24. But again, let's notice briefly how inaccurate that diagram is. It's really, really far out of scale, so much so that actually if you were to draw this diagram properly, the center of this circle is actually meant to be inside the overlap. So I think there might be other ways you could approach this question where that would be slightly misleading perhaps. But otherwise, looking at it the way we've done, I think it is a really nice question that brings some standard techniques together with some good Pythagorean triple knowledge there to make an efficient answer. This is a nice intermediate maths challenge question. Rob, Rog and Roy all painted some fence posts one day. Rob painted 45, Rog painted 51 and Roy painted 48. One of them painted twice as many posts in the morning as he did in the afternoon. A second one painted 3 times as many in the morning as in the afternoon, and the third one painted 4 times as many in the morning as in the afternoon. Who painted the most fence posts in the morning? And we've got some options here. So if we start by thinking about the information we're given here as ratios, the first person who painted twice as many posts in the morning as he did in the afternoon will have done fence posts in the ratio of 2 to 1. The one who did 3 times as many in the morning as the afternoon, it'll be 3 to 1, and the final one will be in the ratio of 4 to 1. And this is going to allow us to work out who is who, because the person who's done them in the ratio of 2 to 1 must have then in total completed a multiple of 3 number of fence posts, because 2 plus 1 is 3, so we're thinking about these posts in sets of 3. In the 3 to 1 ratio, 3 plus 1 is 4, so the number needs to be a multiple of 4, and in the 4 to 1 ratio it needs to be a multiple of 5. Now when we look at the numbers 45, 51 and 48, only 45 is a multiple of 5, so that must be Rob, and then of the remaining ones we've got 51 and 48 that need to be a multiple of 3 and 4, so it must be 51 that's the multiple of 3, because 48 is the only multiple of 4 there, although of course they are all multiples of 3, we narrow it down based on the multiple of 4 and the multiple of 5. So just working out how many posts there are then, it's 51 split in the ratio of 2 to 1, so that would be 34 to 17. The 3 to 1 ratio splitting 48 in that ratio would give us 36 to 12, and for the 4:1 ratio for 45, split in that way would give us 36:9. So we can actually see there are two people who painted 36 posts in the morning. That's Roy and Rob, and that means that we've got Rog only painting 34, so it's Roy and Rob who equally painted the most fence posts in the morning, and so the answer here is D. I bet a lot of students found this hard in the Intermediate Maths Challenge 2025. We've got this isosceles triangle here, and we are given some angles x and y, and told that x, y, and also y divided by x are integers, are whole numbers, and we need to work out what's the largest possible value of y divided by x. So where would we start here? Well, let's look at this isosceles triangle PQR, and we could label some extra angles in here, the two at the bottom. Let's just call them Z so I can write this down algebraically. We'd have then that 2Z plus x equals 180 degrees, and that means that each of those angles at the bottom of the triangle, Z, are equal to 180 minus x divided by 2. So then if we look at the straight line at R, we would have that the angles Z and Y add together to give 180 degrees. So 180 minus x over 2 is the Z, plus Y equals 180 degrees. We could have written this all down without using Z probably as well. So if we just multiply this by 2, we get 180 minus x plus 2y equals 360, and we could rearrange that to give y equals 90 plus x over 2, and we want to get y over x into this question. So if I divide that all by x, that gives us y over x equals 90 over x plus 1 over 2 plus a half. And now we really just need to think about the fact that all of these numbers have to be integers, and we also want to maximize this whole expression. So we're going to maximizing this expression. Now this has just got numbers and an x in it. So, and the x is in the denominator of a fraction. So if I wanted to make this as big as possible, I would make x as small as possible. So really we want to just choose small values of x, but of course we have to remember to make sure to choose this as an integer, and also x and y themselves have to be integers here too. So if we just go through the smallest possible values for x, like x equals 1 here would give us y over x equals 90 plus a half. That's not an integer, so it can't work for this question. If I try x equals 2, again, I get something here that is not an integer. If I try x equals 3, I get something that's not an integer. But when I do try x equals 4, then we get y over x equals 90 over 4, which is 22 and a half, and then when we add on the half, it brings us to an integer, which is 23. So that must be the best answer here. The largest possible value of y over x is 23, and so the answer here is B. What is the remainder when 8 to the power of 8 is divided by 5? This question uses a really important maths challenge trick, which is that the last digit of a product is the last digit of the product of the last digits, and let me explain what I mean by that. So if I do 8 times 8 is 64, and then I want to do 64 times 8, I don't actually have to work out the full calculation, because 4 times 8 is 32, that's the product of the last digits, and its last digit is 2. If you think about how you do the calculation here, the multiplication, then that number is going to end in a 2 for sure. So I can just say, okay, yes, 64 times 8 is 512, but we really could have got that the last digit is 2 without working that out. So I can actually work out the other powers of 8, their last digits, quite quickly here. 8 for 8 to the power of 4, I just need to do 8 times 2, so I'm doing 8 times 8 cubed, and saying the last digit is just going to be the same as the last digit of 8 times 2, which is a 6 then. If I do 8 to the power of 5, I get 6 times 8, and the last digit is 8, because 6 times 8 is 48. You could at this point spot that you actually get a repeating pattern, 8, 4, 2, 6, 8, 4, 2, 6, or you could work out each of those directly, because we've only got to go up to 8 to the power of 8. It doesn't take too long either way. So 8 to the power of 8 ends in a 6. So what's the remainder when 8 to the power of 8 is divided by 5? Actually, I've just written down really what 8 to the power of 8 is here, ending in a 6, but the point is that anything that ends in a 6, one less than it is going to end in a 5, and anything that ends in a 5 is a multiple of 5. So we don't actually need to know the full number of 8 to the power of 8 here. We would know that when we divide it by 5, it would leave remainder 1, because it's 1 more than a multiple of 5. So the answer here is that it is 1, and that's B. This is a nice little intermediate maths challenge question is question 22. So in theory, quite challenging, but actually if you draw the diagram correctly, it's not too bad, I think. We've got a sphere of radius 4 and another one of 16, and they're placed on a horizontal surface so that they touch. We want to know the distance between the points where the spheres touch the surface. So let's just try and get that diagram reasonably neat here. I'm not drawing them in proportion to each other. I just want to have something I can label easily and clearly here. It won't make any difference to the final answer here. So I've got this one that has radius 16, this one that has radius 4. Clearly the smaller one should be much smaller compared to the larger one, but it will work fine. If I put this right angle triangle in here, what we can see is that the top part here is 12, and then that leaves 4 for the bottom. So I've got one side of that right angle triangle of 12 centimeters, and the hypotenuse is made up of the radii of the two circles, so 16 and 4. 16 plus 4 is 20 centimeters. So if we examine that right angle triangle, we've got the sides 12 and 20, and we could just use Pythagoras theorem here and do the square root of 20 squared minus 12 squared. But if you're really paying attention, you'll notice these Pythagorean triples come up a lot in the maths challenges, and that the 3, 4, 5 triangle is what is here, just scaled up by a factor of 4, because 3 times 4 is 12, 5 times 4 is 20, and so the remaining side must be 4 times 4, all the sides being 4 times that standard 3, 4, 5 triangle, which works from Pythagoras theorem because 3 squared plus 4 squared is 5 squared. So however we get it, we find that the remaining side length is 16, and that is the distance at the bottom of that triangle, which is the distance we're looking for, the distance between the points where the spheres touch the surface, and so the answer here is D16. This is a question most students can't solve, but experienced maths challenge students, those who have practiced a lot of the things in the courses that I've made and done lots of past paper questions, will not have too much of a problem with, because it uses some really neat tricks here. So the point P is inside a rectangle, and the distance from P to one corner of the rectangle is 5 centimeters. The distance from the opposite corner is 14, and the distance from P to a third corner is 10, and we want to know the distance to the fourth corner. So let's just start drawing that rectangle and put in all of these points and these distances that we know, and we want to find this final distance D. So if we just split the diagram up further, let's draw dotted lines here to make some right angle triangles and label these sections A, B, X and Y. You can see that I've introduced lots of right angle triangles that I can apply Pythagoras theorem to. So for one of them here, we get that B squared plus X squared is equal to 5 squared. That's the one that has hypotenuse 5, of course, and then for the next one, we've got that B squared plus Y squared is equal to 10 squared, or 100. And for the third one, for the 14 hypotenuse, we've got A squared plus Y squared is 14 squared, which is 196. Now what we want is D, but if we can work out D squared, that will be just as good. We can take the square root at the end, and then we can use Pythagoras theorem once more here, right? Because D squared would be A squared plus X squared, but we've got all the elements we need here, right? If you take A squared plus Y squared, add it to B squared plus X squared, then we would get A squared plus B squared plus X squared plus Y squared. So we just need to subtract the B squared and the Y squared, and that would give us A squared plus X squared. But notice those three parts there that I've put in brackets for emphasis are the things we've already just worked out. So A squared plus Y squared is 196, B squared plus X squared is 25, and B squared plus Y squared is 100. So we do 196 plus 25 minus 100, and that gives us 121, and that means that D is the square root of 121, which of course then is 11, and that's the answer to this question, D, 11. You're going to need really good algebra to solve this intermediate maths challenge question. We've got 2 white roses and a yellow rose cost £5, 2 white roses and 3 red roses cost £10.50, and 3 yellow roses and 2 red roses cost £11. And we want to know what would be the total cost of 1 red rose, 1 white rose and 1 yellow rose. So if we write this down algebraically, calling a white rose W, a yellow rose Y and a red rose R, we would have 2W plus Y equals 500, where I'm working in pence here rather than pounds, of course. 500 pence is £5. 2W plus 3R equals 1,050, or £10.50, and 3Y plus 2R is equal to 1,100. This isn't my absolutely favourite question, if I'm honest, because usually these questions have a really sort of neat algebraic trick. There's quite a bit of work to do in this one, but it is meant to be a test of your algebra here, and we can use the standard trick, at least maybe to simplify things slightly. Usually what happens is, you do something like adding all of these equations together and you get something that works out very neatly. Essentially, when we look at the total cost of everything in the question, we've got 5 red, 4 white and 4 yellow come together for £26.50 or 2,650 pence. So it's not quite a nice symmetric problem where we end up with 4 of each, say, but we can at least see that if we worked out what 1 red rose would be, that would give us quite an efficient way of doing this, because we could then see what 4 of each costs and then get to 1 of each reasonably efficiently. But we do have to do an unusual amount of algebra to get there, I think. So to get to the red rose cost, we can take this first equation, say, look, we've got a 2w in there, and we've also got a 2w in the second equation. There are lots of ways of doing this, by the way. I'm just picking one way through the algebra here. We can make 2w the subject of each of these to get rid of the w. So, 2w is equal to 500 minus y, and it's also equal to 1050 minus 3r. So those things must be equal to each other. And the reason I'm doing this is because that gives me an equation that has y and r in it, and then I've got another equation, the third one here, which also just has y and r in it, and I can solve those two simultaneously to work out y and r. So rearranging, I get y equals 3r minus 550. I could substitute that in to the third equation, or you could use elimination if you prefer. It's often neater, but this way works as well. We've got 3 lots of 3r minus 550 plus 2r equals 1100. Multiplying out, we get 9r minus 1650 plus 2r equals 1100, and so that gives us 11r equals 2750. Thankfully 2750 is a multiple of 11, so we get a nice answer, r equals 250 or £2.50. Actually, when I first looked at this question, I did also look at the answers and say, oh look, they're all whole numbers. Probably they've made these the numbers in this question multiples of 50p or a pound, and actually it might not be that hard to do a bit of trial and error and sort of guess and check here, but I wouldn't really advise that in general, because we might have numbers that come out much more awkwardly, and we just don't know in advance, although it does turn out that way here. But the point is here, now we've got r equals 250, we don't have to work out w and y individually. We can just subtract that r equals 250 from this nice sum that we've got, and that would leave us with 4r plus 4w plus 4y on the left hand side, and 2,400 on the right hand side. So dividing by 4 would give us that 1 red, 1 white and 1 yellow is equal to 600 pence or £6, and then the answer here is C. Is question 25 of the Intermediate Maths Challenge 2025 easy? Actually, I think it might be if you're willing to cheat just a little bit. We'll do it properly afterwards as well, but just look at the answers. They're all whole numbers here. We need to work out the area of this shaded triangle. If we just called all of these side lengths A, B, C, D, E and F for now, without worrying about how they're related, and think about the areas of the triangles, we'd have a half times A times E is 6 here, so A times E would have to be 12. Here we'd have a half times D times F is 5, so D times F would be 10, and for the other one we'd have a half times B times C equals 6, so B times C equals 12. If we just took a bit of a gamble that with only whole number answers to the questions, that all of these numbers might be whole numbers as well, it would be worth 30 seconds of our time just to play around with it here and see if it works, because in fact they've chosen it with quite easy numbers here. If we make D and F 2 and 5, that makes that triangle work. Of course, we also need A plus B equals 5 for this to make sense, so that the sides of the rectangle have the same length. But if we then take these to be 3 and 4, that one works. And if we take these to be 2 and 6, that one works. So actually we've got then that the area of the rectangle is 6 times 5, which is 30, and we get an answer of 30 minus 6 minus 5, or 13 centimeters squared pretty quickly for the shaded area. Of course, this isn't really a good mathematical method to get the answer here, but I bet a lot of people that got this right in the Intermediate Maths Challenge probably did something like this. This is actually a nice question if you do it properly, and if we wanted to do it properly we'd have to do something like this. Let's call these side lengths x and y and this length a, then we'd have a half times a times x is equal to 6, so a would be 12 over x then, and we can not refer to a anymore in this question. Then because the height of the rectangle is y, this part here would be y minus 12 over x. If we call this bit b temporarily, then similarly we would have a half times b times y equals 5, so b is equal to 10 divided by y, and we don't need to refer to b again in this question. Then again, because x is the total width of the rectangle, this part here would be x minus 10 over y. So where do we go from here? Well, we haven't actually used that bottom left triangle yet, so let's use the area of a triangle formula again. A half times x minus 10 over y times y minus 12 over x is equal to 6, and if we just multiply that by 2, we get that same expression there without the half equals 12. And the really clever trick here is to say, let's look at what we've got in these brackets. There's a y and an x in the denominator, but if I multiply that first bracket by y, we'd get xy minus 10. Of course, I would need to multiply the right hand side of the equation by y as well for this to be valid. And if we do the same thing with the second bracket, we would multiply it by x, so we would get x times y minus 12, and then of course we would multiply the right hand side by x as well. If you look what we've got here, we've only got x times y as the sort of algebraic bits of this equation, so let's just call that a. Why am I calling it a? Well, because x times y is actually the area of this rectangle, and it's what we need to work out the shaded area as well, so it's a nice thing to substitute here. So we've got an equation, a minus 10 times a minus 12 equals 12a. And this is a quadratic equation. I just need to multiply it out and do the usual sorts of things I do with a quadratic equation. So let's multiply it out. A squared minus 10a minus 12a plus 120 is equal to 12a. Subtracting 12a from each side and combining the terms, we get a squared minus 34a plus 120 equals 0. And then choose your favourite method to solve this equation. Of course, we know it's going to work out nicely here. We know it's going to factorise, so we can factorise it here as a minus 30 times a minus 4 equals 0, which gives us the possibilities a equals 30 or a equals 4. And a equals 30, of course, because it can't be 4, because we already have 6, 6 and 5 units of area in the rectangle, so the area must be at least that. 30 is the only thing that makes sense here, and then we get that the shaded area, as before, is 30 minus 6 minus 6 minus 5, which is 13 centimeters squared for the final answer here of B. Well done. If you're still with me, I hope that was useful. If you want to keep going, here's a video with every question from the 2024 Intermediate Maths Challenge in a format very much like this one.